Supervolcanoes, the very term strikes fear into our hearts. These gigantic beasts that lie dormant beneath our feet are ticking time bombs that could spell disaster if they were to erupt. But how exactly do supervolcanoes form, and what would happen if one were to blow its top? That's what we'll explore today. But first, let's take a look at what makes a volcano a supervolcano. It all has to do with their sheer size and the amount of material they can move when they erupt. Unlike your average volcano, which is classified as a lava mountain or a mafic volcano, supervolcanoes are what's known as a caldera-style volcano. But before we get into the differences between these types of volcanoes, let's talk about how volcanoes form in general. Volcanoes are formed when rock deep within the Earth's crust melts and recools. This molten rock, also called magma while it's still under the ground and lava once it erupts, is lighter than the surrounding solid rock, so it rises to the surface. As it continues to rise, it collects in chambers or reservoirs below the Earth's surface. When the pressure from the magma exceeds the strength of the rocks above it, the result is an eruption. Now let's compare the formation of a typical volcano versus a supervolcano. A mafic volcano forms when magma from the Earth's mantle rises up through the crust and creates a cone-shaped mountain. The magma is rich in magnesium and iron, which gives the volcano its dark color. Mafic volcanoes are further categorized into different types based on their shape and size, such as shield volcanoes, stratovolcanoes, and cinder cone volcanoes. Shield volcanoes are the largest and are created by low-viscosity magma that erupts over a long period of time. Stratovolcanoes, also known as composite volcanoes, have steep sides and are formed by alternating layers of lava and ash. Cinder cone volcanoes are the smallest and are formed by the accumulation of volcanic fragments known as tephra. On the other hand, supervolcanoes don't form in the same way. Instead of building up a cone-shaped mountain, supervolcanoes form when magma chambers are filled with highly viscous magma. This thick and sticky magma is often rich in silica, which makes it more felsic in composition. As the magma chamber fills up, the pressure increases until it ruptures the overlying rock, creating a caldera. The magma then erupts, not out of a central vent, but from the newly created opening in the Earth's surface. Caldera is a Spanish word meaning cooking pot, which is an apt description of these giant craters. Over time, new magma can fill in the caldera, leading to multiple overlapping craters and vast volcanic complexes. What sets supervolcanoes apart is their sheer size and the amount of material they can move in a single eruption. They can be tens of kilometers wide and hundreds of meters deep, and during an eruption, they can eject more than 1,000 cubic kilometers of material, making them among the most powerful natural phenomena on Earth. To put this into perspective, the largest historic eruption was that of Mount Pinatubo in the Philippines in 1991. It ejected around 5 cubic kilometers of material and caused significant damage and loss of life. In contrast, a supervolcanic eruption is over 200 times more powerful than Mount Pinatubo. Earth is home to a handful of supervolcanoes, and scientists continue to debate whether any others exist. One of the most well-known supervolcanoes is located in Yellowstone National Park in the United States. Yellowstone Caldera is actually a series of overlapping calderas created by 3 major eruptions in the past. The most recent occurred around 640,000 years ago and was one of the largest in Earth's history. Despite its reputation, Yellowstone is not considered to be an active supervolcano because the magma chamber is not currently recharging. Instead, it's in a dormant state. Scientists closely monitor Yellowstone for any signs of unrest, such as increased seismic activity or changes in the heat flow from the ground. Another famous supervolcano is located in New Zealand and is known as Taupo. Its most recent eruption was even more powerful than that of Yellowstone, but it occurred much more recently, only 26,500 years ago. This eruption was so massive that it left a lake of volcanic ash, known as the Taupo volcanic zone, which now contains the lake that inspired its name. But perhaps the most intriguing supervolcano is one that lies beneath the Atlantic Ocean. The solitaire triple junction is located near the Azores Islands and was formed by the hotspot volcanism. Interestingly, this supervolcano is thought to be the product of a mantle plume, a tall column of hot mantle rock that originates deep in the Earth's interior. The plume acts like a heat pipe, bringing magma up from deep within the planet and creating a chain of volcanic islands. The Azores archipelago is actually the above-water portion of the solitaire triple-junction supervolcano. The islands were formed over a hotspot that has been active for several million years and shows no signs of stopping anytime soon. What happens if one of these giants erupts? The consequences would be nothing short of catastrophic. During the initial explosion, a massive amount of ash, gas, and rock would be ejected into the atmosphere. The force of the blast would flatten forests, destroy buildings, and level entire cities within a radius of hundreds of kilometers. Hot flows of lava would race down the sides of the volcano, incinerating everything in their path. Pyroclastic flows, consisting of hot gas and solid fragments, would surge through valleys, destroying everything in sight. But perhaps the most dangerous aspect of a supervolcanic eruption would be its impact on the global climate. The massive amount of ash and gas injected into the stratosphere would block out the sun, leading to a prolonged period of darkness. This would disrupt the Earth's delicate climate balance, leading to widespread crop failures and food shortages. Global temperatures would plummet, leading to a so-called volcanic winter. The ash and gas would also cause widespread respiratory problems, making breathing difficult for millions of people worldwide. In the aftermath of such a disaster, survivors would face another threat, the collapse of society. Without food, water, or medical care, large populations would be at risk of starvation and disease. Infrastructure would be decimated, making it difficult to transport food and other essential supplies. The economic impact would be devastating, with many countries struggling to recover for years or even decades. The likelihood of a supervolcanic eruption in our lifetime is incredibly small. Scientists carefully monitor these volcanoes, and any signs of unrest are quickly identified and studied. In the event of an impending eruption, evacuation plans are already in place for many of these areas, but that doesn't mean we won't experience smaller volcanic eruptions. In fact, there are several volcanoes around the world that are currently showing signs of activity. For example, Mount Vesuvius in Italy, which famously destroyed the Roman city of Pompeii in 79 AD, is now rumbling once again. Scientists are closely monitoring the volcano as it shows signs of unrest. If it were to erupt today, the consequences would be catastrophic, as the densely populated region surrounding the volcano is home to around 3 million people. Mount Vesuvius is just one example of the many volcanoes that could erupt in the near future. While a supervolcanic eruption would be a rare event, we must still prepare for other types of volcanic activity. By studying volcanoes and understanding the risks, we can better protect ourselves from their destructive power. Volcanoes are a fascinating and powerful force of nature. They remind us of the immense power that lies within the Earth's crust, and the importance of understanding and respecting the natural world around us. Whether it's the towering peaks of Mount Fuji or the rumbling depths of Mount St. Helens, these geological wonders continue to captivate and inspire awe in those who behold them. So let's continue to explore and learn about volcanoes so that we can better understand and appreciate these incredible natural phenomena. Who knows, maybe one day we'll even harness their power for our own benefit. Thanks for watching this episode. If you want to learn more about volcanoes, check out the links in the description. And if you liked the video, don't forget to give it a thumbs up and subscribe for more science videos.